You don't have to write this. Okay. So we can actually perform operations on functions in the same way that we perform operations on our numbers. Like 2 plus 2, we could add a function to another function. 3 minus 2, we could subtract a function from another function and multiply and divide. All right, so that's what we're going to look at first. So just from the little chart that you looked at, what are they wanting you to do with those two functions?
Add them.
They're wanting you to add them, right? So that's exactly what we're going to do. So we're going to take f of x and we're going to add that to the g of x. All right, so replace your f of x with the actual function itself, which is the 4x squared plus the 3x minus 1. And then bring down your plus, and replace your g of x with the actual function, 6x plus 2. So what you will do at this point is basically just simplify. And we will simplify by combining our like terms. And when we are working with our polynomials, we always write them in descending order. So in this case, you're by the power. In this case, x squared is our highest power, so that will be listed first, then the x, and then, of course, our constant. So our 4x squared does not have, there's not another 4x squared, so it stands alone, so bring that down. Now you're going to go to your x terms, because that what would come next in descending order. That gives us a 3x and a 6x for a what? 9x. And our constant, that's our -1 and our 2, and that would give us a 1. Okay, and that is your answer. All right, so for this next one, we're going to use the same f of x and g of x, but this time we are actually going to do the subtraction. All right, so let's do that. Let's write it. So this really means f of x minus our g of x. Make sure that when you are working with your subtraction, you don't flip the order. So we're going to do like what we did before. We're going to replace with the actual functions. So our f of x, again, is the 4x squared plus the 3x minus 1. And now we're going to look at the negative sign. This is where we change it up just a little bit. We're going to bring that negative down. Then we're going to bring in that g of x. Since you are subtracting two terms, you must apply the negative or the subtraction to both of those. So you're going to put it in parentheses, like that. And then what you'll do at this point is you will distribute. So bring down your first function unchanged. Now apply the negative, so that would give you negative 6x and negative 2. And you'll notice what would happen if you didn't distribute. If you didn't distribute, you would not have made the 2 a negative. And then you're wrong at that point. Yeah, and now you're just back to simplifying. just like we did on the first one. I like terms. Again, in descending order. So again, 4x squared, obviously again is a standalone, so bring it down unchanged. What happens to our x terms this time? Yeah, and we so then we get negative 6x. 3, yeah, I did that earlier too. Negative 3x, and then our negative 1, negative 2 gives us a negative 3. All right, let's see how you did. Your first two terms, x times x squared, x cubed. All right. Then your 2 outer, that's the x and the negative 4, so that would be negative 4x. The 2 insides, so that's the 2x squared, so that'd be 2x squared. And then your last 2, so that's the 2 and negative 4 for negative 8. Now usually when we do FOIL, we can usually add the outer and inner terms because they usually end up being like terms, but it doesn't work this way because of that x squared. It kind of messes it up. So we actually have no like terms, but we do need to do something else, which is what? Put it in order. So put it in order for me. So our highest power is what? X cubed. So we'll start with that one. Then after your x cubed, you'd have to do the 2x squared minus 4x minus the 8.
I forgot what the FOIL method was. I was like, what is this?
So for our last example on the division, we're going to do the P of W divided by the F of W. And so we will write it like this. So our P over our W. And we cannot simplify this. So what we'll do is we'll come over here and we will set that denominator equal to 0 and find that restricted value. So if we solve it for 0, we end up that W equals negative 11/7. So to show that it cannot be a part of the answer or part of the domain, we will write it like this.